Good evening, everyone, and thank you all for coming to the seminar. The health seminar is very important to our breed because we need to do the research for many things, including SAS, atopic ureters, cancer. There's a lot of issues in our breed, and when we can get one of the doctors that are doing the research in our breed to come and speak about it and answer all of our questions instead of rumor mill or what you heard or what you think. This is where you get the answers to your questions about breeding issues, about lines that carry this, hereditary, in utero, how does it start? So this is why I'm excited about having Dr. Stern from UC Davis here. Originally, he was from Bristol, Ohio, and Josh Stern is a veterinary cardiologist and geneticist. He is currently an assistant professor and chief of service in cardiology at the University of California at Davis. He works in the veterinary medical teaching hospital at UC Davis and is a member of the Center of Companion Animal Health and the Center of Veterinary Genetics. His laboratory is devoted to the studying of cardiac genetics and specifically the condition of subaortic stenosis, SAS. He is a long-standing golden retriever enthusiast and is devoted to reducing the prevalence of inherited diseases in this breed. Without further ado, I welcome Dr. Stern.
Okay, can everybody hear me okay? Yes? Great. All right, so was that something other than a yes? Okay. So I'm going to start off with a little bit of introduction and talking about SAS. And stop me at any time you have questions. We can do this pretty informally. I think some of the slides will be really boring depending on your level of knowledge or interest. And so we'll try and liven that up by answering any questions that you have. I love golden retrievers, and that's a fair warning. So I've put all my golden retriever pictures in here because I get in trouble. The students yell at me when I put all pictures of my dogs to the talk. They like to see other dogs in cardiology. So you guys get all goldens. So before I start talking about my research, it's rare that I'm more excited about anyone else's research than my own. But you guys are part of a study that is more exciting than my research, and that's this Golden Retriever Lifetime Study. If you haven't had the opportunity to check it out or enroll your dogs, you should all enroll at least a dog, and you should do it soon because they only have 900 spots or so left. And I think having a nice equal representation of golden retrievers across many different categories and areas of this country is really, really important. This is my dog, Florin. She unfortunately passed away from one of the study cancers all too soon. And now I'm participating in this study with my own dog. So caninelifetimehealth.org, please, please, please think about that. This is Lyra, who is participating in this study. She's number something, 203 apparently. She's a lifetime participant. She's my research partner. She's unfortunately a guinea pig for just about everything that I try in the laboratory, and she doesn't seem to mind. And she's often very bored at work in my office. So I have some acknowledgments to make. All of these studies have been ongoing for quite some time, even before I got started in veterinary cardiology and genetics. Of particular interest, Morris Animal Foundation has supported almost all of my training as a veterinary cardiologist and geneticist. They've given to studies that relate to Goldens and subaortic stenosis and have been really, really influential in golden retriever research in general. These three institutions were really big in training me as a cardiologist, as a geneticist, and supporting all of this research. I started at Ohio, went to Washington, then to North Carolina, and now I'm in California. So I'm trying to take a tour around the greatest veterinary universities in the country. That's my goal. Lots and lots of people have personally helped me out. You guys, the Golden Retriever Club of America, have definitely funded a fair bit of the research and information that I'm going to present today. And then you have some partners in crime with the Newfoundland Club of America and the Rottweiler Club who have also given me some funds to continue SAS research, which is kind of benefiting all breeds. Lastly, American Kennel Club Canine Health Foundation is a huge parent organization for lots of the research. This is my dog Florin again. This slide is to remind me that I actually started out in golden retrievers quite some time ago, and I needed to add that as an acknowledgement. Specifically, Judy Preston, who isn't here today with Mirror Dream Golden Retrievers, got me started in Goldens when I was in junior high, I think, when my parents wouldn't buy me a golden retriever. I had to work for Judy. And it was all those trips to Dr. Hutch's office to perform AIs and C-sections that made me decide to be a veterinarian. And since then, I've been a golden retriever owner and lover extraordinaire. So for today's talk, we're going to talk a little bit about the background of SAS, what we know about it, some genetic studies in golden retrievers, Newfoundlands, and Rottweilers, and how they kind of coexist, whether they inform one another or not, differences amongst those breeds, the mutation discovery in Newfoundlands, which is a really hot topic right now and important for you guys to understand how of little benefit it is to you, and future directions for this study and what we actually know in your breed, okay? If there are any Newfoundland breeders in the audience, we can talk afterward, okay? All right, so SAS is the second most common congenital heart disease in dogs, period, not just golden retrievers. Oh man. All right, I'm pressing buttons that I shouldn't be. It's because I'm just trying to juggle this. I usually only juggle this and coffee, not this and a mic. So it's the second most common congenital heart disease in dogs, period. Really, really common and overrepresented in golden retrievers, Newfoundlands, and Rottweilers. The thing about this disease that's so difficult and why it's of such interest for studying is that the clinical signs of this disease vary widely. I'm not sure why that happened. Okay. So the clinical signs of this disease vary really, really widely. Mildly affected dogs can have a completely normal lifespan and quality. They can go completely undiagnosed in the population and therefore get propagated and bred, okay? And that's why many of these breeds have such a big problem with subaortic stenosis today, is because of this really mild form of disease. Severe dogs, however, are the horror stories that we all hear of SAS, where these dogs die suddenly by 19 months of age without any therapy. If we give them a beta blocker or an oral drug, we might be able to get them to about 4.5 years of life before sudden death, congestive heart failure, or some other complication of heart disease. The actual disease itself is this ridge of tissue right below the aortic valve. And it seems like cardiologists are making it up a lot of the time when we show you guys images. So I want to walk you through one image to show you what exactly we're looking at. But this is a very identifiable image and SAS lesion. Many, many dogs have very subtle lesions, and that's the whole reason cardiologists go to school to look at echoes, is because of how subtle this disease can be. This is an image of a dog's heart. This is the left ventricle. This is the aorta and the aortic valve. And this guy hanging down here just below the aortic valve, this little bright bit of tissue, is the subvalvular ridge or ring. And this one is really apparent. Okay, so you can find out just how subtle this disease can be, because this ridge is a slam dunk for this disease. Okay, this would be a severely affected dog. Now, the heart itself, because of this lesion, has to work really hard to eject blood out to around the rest of the body. And it's kind of like the heart's going to the gym every day. That muscle gets thick and thick and thick. And when your heart muscle gets too thick, you can no longer get blood flow to your heart muscle, and you end up with arrhythmias, and that's the general cause of the sudden death in this disease, is that the heart muscle gets too thick, the body can no longer perfuse that muscle adequately, and we get ischemia or infarction, just like a heart attack in a person, that can cause arrhythmias, okay? Because of this lesion, they also get a big aorta. That blood flow is moving at a really rapid rate. Their aorta gets big, and it can also leak. They get aortic insufficiency. And so we kind of tabulate all these findings when we do ultrasounds of hearts to say how severe the disease really is, okay? Diagnosis, well, this is the bad news. The bad news about this disease is that the gold standard diagnosis is done post-mortem. So nobody likes to hear that, because it means that we're not going to be very effective at eliminating this disease from breeding populations. We have to kind of develop a surrogate test. And that surrogate test for us is that echocardiogram or angiography. This was the old way. So if you've been breeding Goldens for a long time, you may have had a Golden Retriever that had an angiogram instead of an echo. But in the last 15 or 20 years, it's all been diagnosed by echocardiography or ultrasound of the heart. Okay? Now, because that lesion can be so subtle, however, we're not really going to use the picture as our diagnosis. We need to use a surrogate marker for diagnosis. And that surrogate marker of that lesion is going to be the speed with which blood leaves the aorta. So aortic flow velocity. That's the number that everybody's always comparing when you're breeding dogs and worrying about producing SAS, is the aortic outflow tract velocity. And I'll show you some normals on that later. I tossed this slide in here to bring up a point that is really controversial amongst cardiologists and breeders and everybody alike. And so this is meant to be a little unsettling. It's okay. I don't really know that I believe this entirely, but I'm going to tell you some points about it that I think are really important. And that's that almost all breeding age Golden Retrievers have a heart murmur. If you get them excited enough, you can develop a heart murmur in just about any breeding age Golden Retriever. My own Goldens have always done this. If you run them around long enough and then pop them up on the echo table, you can hear a heart murmur straight away in these dogs. And so that means that listening to their hearts alone, if we're trying to screen 1- and 2-year-old Golden Retrievers, might not be the best way to identify subaortic stenosis. Okay? Now, if you listen to a dog and it has absolutely no murmur, and it's a young, healthy Golden, that's great. I think that's good enough, okay, for the most part. But if you hear a heart murmur, it doesn't tell me much of anything in Golden Retrievers. If it's super loud, sure, it's probably SAS. If it's mild or moderate, I think all bets are almost off in this disease. And so I have seen really excited Golden Retrievers that I would swear had subaortic stenosis until I echoed them, and exactly the opposite of that as well. And so unfortunately, when you have a Golden Retriever with a murmur, echo right now is the only test we have to discriminate, and there are some big flaws with that test too. Okay? And so I bring up some other points because I inevitably get called about this all the time, and that is, hey, Dr. Stern, you screened my dog. You said his aortic velocity was 2.6. You were wrong. I went somewhere else, and his aortic velocity was 2.48. How could you do that, right? Well, here's the story. I like to stand behind one really fun fact, which is physically, you can't overestimate aortic velocity. By the physical properties of blood flow and Doppler, the highest number is the most accurate, which is a little unsettling if you're going for a small number. But it makes me feel better when I get called about being off by 0.1 meters per second. The thing about that is the body can overestimate aortic velocity, meaning if you're really excited or really stressed, your aortic velocity is going to be higher. It's the same for us, and it's the same for dogs. Okay? And so conditions under which tests are performed have a lot to do with the absolute number that you get. Okay? Yes?
Quick question. What is your cutoff number? Some vets use one number, they use another. And the second part of that question was exactly what you just said. I had a very well-known cardiologist pummeling with her students, 5 guys hammering this guy down on the table to get the echo.
Yeah.
And it was on the cutoff line of what you might consider or not. And I was like, you just put a treat on his nose or lay there calmly, you know, like, and then big 5 guys.
Yeah.
So with that, I mean, kind of.
Yep. So the question becomes, what is a normal cutoff value and what are normal procedures under which to obtain those values? And that's really, unfortunately, really hard to get cardiologists to agree on, okay? And it isn't that we haven't tried. We talk about this every year at our national meeting, and every year there is some dissension among the ranks about what's really normal. What we've settled on is we know what's absolutely normal, and we know what's really likely to be pretty darn abnormal. And the more we talk about it, the wider this zone in the middle becomes, where we call your dog that really dirty word, equivocal. Okay? Everybody hates that word. I hate that word. There's nothing I would rather do than say your dog passes or doesn't pass. I hate the equivocal because it means that we don't know anything right now. Okay? And so I'm going to tell you how we're trying to separate that out a bit, and I'll give you the cutoff values that we use. I promise. Okay. So we already said that we can see severe dogs live a very short time, and we can use beta blockers to get them maybe to 4.5 years at best, but it's a really terrible disease. It's because the aortic valve and subvalvular stenosis doesn't really behave like other valvular stenoses in the heart. We can't just use a balloon, open it up, and make it all go away. That ridge or ring of tissue tends to grow back, and there are certainly some people out there who have tried some pretty elaborate things to do this, okay? We've tried to balloon them to open up those ridges and rings. We've tried to do open heart surgery and cut out those ridges and rings. And most recently, we've tried to do a combined procedure where we put little razor blades on the outside of our balloon, so we kind of cut the ridge or ring, and then we go on and dilate it. And really, right now, none of those options are shown to provide survival benefit beyond the 4.5 years. Okay? So I want to just be careful that we don't think that there's a way to fix this disease. That new option, that last option, hasn't been around long enough to know for sure. Okay? So we'll wait. The jury's still out on that. But to me, in my mind, if I can't cut it out and make it better, and I can't stretch it out and make it better, then why would cutting and stretching help? That's just my own philosophy, but we'll wait to see the research on that for sure. So, well, I thought I had cutoff values in here for you guys. Before we go too far away from the cutoff value question, I'll tell you what my cutoff values are. If you follow what the cardiologists tried to establish as ARCH guidelines, which was this group of cardiologists that got together and said, what number do we really want to use? We established 1.9 and below as normal. We established 2.4 and above as abnormal. And we established 1.9 to 2.4 as who knows. Okay? Now, we're amending those a tiny bit. In practice, personally, I clear dogs 2.0 and below, completely clear. Okay? And I ding dogs 2.4 and above, okay? And I do the equivocal from 2.0 to 2.4.
Does it matter how you got that result, like I was saying?
So I personally try desperately to snuggle with all golden retrievers that come in. So in my clinic, there won't be 5 people holding down a golden retriever, and I would tell you the only time that I would allow a 5-person holding down golden retriever result to go through the clinic would be if it was a normal number, right? If it was 1.8 and 5 people are holding them down, then it's normal. But under extreme stress or duress, I would say that number is probably null and void, unless it's really abnormal, okay? Really abnormal numbers are always really abnormal, okay? This stuff about I got a 3.2 and later it was 1.6, isn't true, okay? If that happened to you, somebody was really wrong, okay? That wasn't, your dog didn't do that with stress.
You're saying the excitement of the dog won't change it that.
It won't take it dramatically. In fact, most of the time, the differences that I see from excitement take a normal dog to equivocal or take an equivocal dog to affected. They don't take a normal dog to affected most of the time. And they don't take you to extremely affected most of the time, okay? Now, everybody will have one exception to that rule in recent memory, okay? But the 1.6 to 3 point something doesn't happen with that. That's a cardiologist or ultrasound machine error somewhere, probably, okay? And I don't like to point fingers at those when they happen. I just like to say, here's the number today, and it was collected as best as I can collect it. Do with it what you want, okay? And I do think that those numbers need to be collected in a certain way in order to say that they mean something. And that certain way for me is listed on your OFA form, and it is by subcostal continuous wave Doppler. okay? If your cardiologist that's providing your screenings for SAS isn't putting that ultrasound probe in the belly and doing the subcostal view, those numbers to me aren't accurate, okay? We know that subcostal provides the most accurate velocities, or the highest velocities that we can obtain, and that's what our cutoffs are based on, okay? So I don't like it when we don't do subcostal velocities. I don't think that they're very accurate. Now, if it's high by some other method, it's going to be high because you can't overestimate it.
Like, what other method would you say?
So some people will take this image from the left side of the chest and not from the diaphragm. Okay? I do both. When I echo dogs, I do both. But if I'm at a screening clinic, I do diaphragm. Okay? Because it's the one number that matters the most to me. That number is going to be the highest number, and since you can't overestimate aortic flow velocity, I want to have it obtained that way. Okay? That might not be a popular remark amongst cardiologists, but if they sat down and they looked through all the records of all the OFA clearances and all the genetic samples that we have on SAS, I can tell you they would want it to be subcostal. Okay? Yes.
Can we go back a second to your comment that clear bioexpectation doesn't mean much to you?
Yeah.
That's all breeding. Do you think all breeding stock needs a doctor?
No, I don't think that your breed, I don't think everybody in, was the question, does everybody in your breed need a Doppler?
Does it all breeding stock?
Oh, does all breeding stock need a Doppler? Would it make my job as a geneticist a whole lot easier? Yes. Do I think that you see dogs that are absolutely free of a heart murmur by a cardiologist that then Doppler super high and have clear SAS? No, I don't. I don't think that's true. I think if you have a dog that has no heart murmur by a cardiologist and then Doppler super high, something is dramatically wrong. I don't know what that thing is, but I can say I've never had a dog on my echo table that had a velocity of 2.4 or above that I couldn't hear the heart murmur. Okay, but I'm a cardiologist, and I'm doing these all in a very standard way, where it's quiet, there aren't kids screaming, there aren't 7 puppies surrounding the dog that I'm listening to. I mean,
It's not a dog show.
it's not, and it's maybe not a dog show. I wasn't going to go there, but because I do breed screenings at dog shows, and I think they have a really valuable place, right? But I don't know that their value is in discriminating that equivocal zone. That's one thing that I'll say. If your dog's equivocal at a dog show, I think you should go see a cardiologist, right? If your dog has SAS, you're going to need a relationship with a cardiologist anyway. So bite the bullet and do it. You might just be happily surprised because your dog was just stressed out about being around 400 other happy golden retrievers in a loud environment. Okay, they're often loud environments. The best one I've done so far was in a bathroom. It's the quietest I've ever had. They put me in a bathroom to do my screenings, but usually it's much louder than that. Okay? All right. So the genetics of this disease are long-standing and very, very interesting. In 1976, Dr. Patterson started looking at this disease in Newfoundland. He found that it was a dominant disease, okay, which blows people away, right? But that's what he found, and I'm going to make an argument that that's what it is. We know from studies that we did in our lab and funded by you guys that this is inherited in golden retrievers. There's no question affected dogs produce affected dogs, okay? They might not always produce affected dogs, but they produce some affected dogs. It's really rare in human beings, and so I like to use that as an excuse as why it's taking me so darn long to fix it, right? Because we don't have an idea where to start in the genome, right? It's not like hypertrophic cardiomyopathy, where there are 1,000 known mutations in people, and we could just start screening for them in cats. It's exactly the opposite. There's no roadmap in this disease. So we did this study in golden retrievers, where we looked at inherited subaortic stenosis. These dogs do not have subaortic stenosis, not that you could tell by this picture, but they are terminally cute. And what we did was we did a lot of echoes on dogs, and we paid attention to the findings of SAS and supportive information of SAS to try and characterize this disease in your breed, because believe it or not, SAS amongst breeds is not the same, okay? Your breed, to your credit, has done a lot to try and remove severe SAS. And you might not like to hear the answer of what happened when you did that, but I think what happened is you created a whole lot of equivocal SAS. And so you have dogs out there, there are lots and lots of equivocal dogs, and there are few severely affected dogs. But now everybody's going, well, what do we do now? Is this or is this not SAS? And that's what we're trying desperately to sort out for you. And so in this study, we looked at 73 golden retrievers. We collected pedigrees, and we did full echoes, not just the breed screening echoes. Okay? And we defined equivocal. So here we changed our numbers because we wanted to be. Yes. And so we defined their affected status differently than the numbers that I told you I use, because for genetics, we want to err on the side of caution. So we want to make sure that normal dogs are really normal and affected dogs are absolutely abnormal. So I even broadened this category. So we used 2.5 and 1.8, okay? And everybody in the middle we threw out. We looked for all the different problems on the echo, and what we did was we combined this disease status score. We said, how severe is their SAS? How many things do they have wrong with them on their echo? And what we found, basically, we don't need to know about statistics, is that we ended up with 32 affected golden retrievers. Okay? Now, that's not because there are, out of every 73 golden retrievers, 32 are affected. We were trying to look at SAS, right? So we put a call out to you guys, and you guys did your thing. You rallied your troops, and you said, who's got SAS dogs that's willing to own up to it and go see this cardiologist? And so that's why we got 32 dogs, okay? This is not the prevalence of this disease in your breed, okay? I don't know what that is, okay? Of those 32, about a third of them had a thick left ventricle. 2/3 of them had leaking across their aortic valve. And 2/3 of them had an identifiable ridge below their aortic valve. Okay, so that really clear thing that we see on echo, about 2/3 of them had that. And then we did our statistics, and we found out some interesting information. For every 1 meter per second you are above what we would call clearly affected, you had this increasing likelihood to have all these other signs, all these other bad things on your echo. And so this was an argument to us that if you have an equivocal dog, if your dog tests in the gray zone, you should go to that echocardiogram and look for other signs of SAS, okay? Don't just go by that number. Let's look for other things that might say we're dealing with or not dealing with SAS. And so to me, those other things are leaking across your aortic valve, thickening of your left ventricle, or something abnormal below your aortic valve that's a clear lesion. And so when I have equivocal dogs, these are questions that I ask myself. Hey, is there a ridge? Yes or no? Is there AI? Yes or no? Is there a thick left ventricle by measurement? Yes or no? And if you're my client and you're equivocal and you have any of these things, I say, hey, you can go get a second opinion. In fact, you probably want to if this is a really important dog to your breeding lines, but chances are it's a real affected dog that just has really mild disease. And here's the good news. Those mildly affected dogs tend to live forever, but they can pass this disease on. Okay? So that's what I tell people.
If you have nothing else wrong.
If you have nothing else wrong, I say you should probably get that retested when they're not spazzing out on the table. Okay, yes.
Study dogs have multiple issues wrong, or one or the other?
They can have a cumulative score. So they can have all of those things. The most severely affected dogs have all of these things. Yep. Yes.
And that's done with ultrasound?
Yes. It's done by echo, but it will not, likely it will not be collected on screening echoes done on the fly at shows or whatever.
On the standing or laying on the
Yes.
echo. Is that a standing or laying?
The subcostal aortic velocity is laying down generally, just to get the image that I want. And that's fairly standard amongst I mean, so cardiologists are trained all over the place, and there are about, I don't know, 300 or 400 of us now, total. So it's possible that you'll go to somebody who says, you know, in my experience, this number is very accurate this way. All I can tell you is what all the research is done on, and that's on subcostal continuous wave velocity. Yes.
What about an internist doing the echocardiogram? How is that different from a cardiologist's point of view?
I think internists are lovely. But the truth of the matter is, there's a reason that we exist, and so I would say
values can't be the same since it's a very specific value?
I think there are amazing internists that do great studies, and there are amazing radiologists who do great studies, and there are amazing cardiologists who do great studies.
Okay.
But I would not trust an echocardiogram to clear a valuable breeding animal that was not performed by a cardiologist. I just wouldn't. I've had way too many experiences that argue the opposite, and at least in my training program, so at UC Davis, our radiologists who go out and can do echo spend about 2 weeks with a cardiologist learning how to do it. Okay? My resident spends 3 years with me learning how to do it. That's the difference. Okay? 3 years, 2 weeks.
What about an internist? How long do they do it?
Oh, anywhere between 0 days and several weeks.
Okay.
I mean, they don't get extensive ultrasound training. If they do that, most of them do it on their own time, and they get extra training on their own. Okay. Now, echo's a skill, it's not a talent, right? So anybody can learn it and get good at it, right? But if you want to talk to me about about an echo report, we're talking about a cardiologist echo report. I think there's no real reason not to do that. Right. I don't think you're getting a cost benefit on any of those other options. If you think you are, find a new cardiologist. Okay? All right, so this is just showing us that disease status score, so all those cumulative things went up. We had more of all those problems as your aortic velocity got higher and higher and higher. And so that's our rule for you should look at all these other things in equivocal dogs. Okay? That's probably boring. Pedigree evaluation of these dogs. Well, these are 2 families that I wanted to highlight for you guys so that you can see something that is really frustrating in golden retrievers. Open circles and squares are normal dogs. Their aortic velocities are next to their symbol. So this is a male with an aortic velocity of 1.6. Most of you would jump up and down for that aortic velocity in a breeding dog. This is a female with an aortic velocity of 1.7. And look at these affected puppies, 2.7 and 3.7. Well, isn't that annoying? Really annoying. Now, just to muddy the waters, though, it doesn't always happen like that, does it? Here's an affected female that produced 3 affected pups. Okay? So the pattern of inheritance of this disease is not simple. It is not carrier affected clear. It won't be that easy. It's not going to be that easy. Okay? It's going to be, I have the genes that can potentially lead to SAS, or I don't, and I have maybe 1 copy or 2 copies of it. Okay? That's what we know from all these other breeds. This pedigree evaluation says this is autosomal dominant with incomplete penetrance, meaning you can have the genes and not develop the disease. And that is a really frustrating type of inheritance to have, but it's unfortunately really common in all heart diseases in kids, really common in all heart diseases of dogs that we know about so far. Autosomal dominant, incomplete penetrance. So when you get a genetic test, this is a really important point. When you get a genetic test for a heart disease, you don't test and remove, okay? You don't just do the genetics and say, all dogs that have this genotype are gone from the breeding population, that is it, okay? You guys will be dealing with a whole world of problems if you do that, okay? Because what this means to me is that this gene that causes SAS is running rampant probably in the breed, okay? And you're going to want to be really careful about how we strategically slow down the production of puppies that carry it, okay? Strategically is the key word. Don't throw the baby out with the bathwater. You'll be sorry. Many breeds have done that, and they've ended up with other problems. Okay? Don't be that breed.
So, I'm going to ask the question, the other dog is SAS mild.
If I have a dog that has SAS, I would not breed them. Absolutely. I think that is a clear indication to me that they definitely have whatever gene it is. And I would say if they have SAS, I would not breed them. Now, everybody's going to have a story about it being the world's change in Golden Retriever, the end of an era. No genotype or no genes like this exist ever again. And if that's the case, you know, do your diligence and do whatever you want. Okay, we're not here to tell you not to do it. What the ones that I wouldn't throw out would be those that we know have the gene but don't display disease. Okay, that's what I'm worried about happening. We don't have a gene yet, though.
The sire is produced.
Yes.
And the get is clear. He could be adherent.
He could have the genotype, or the dam could have the genotype. Yep, we don't know which one. And so my recommendation in those breeding scenarios is not to throw anybody out, but to echo progeny, if you can, to get a good idea if you're having a problem in your line, okay, and to go to outcrosses for that dog, okay? Whatever crossing produced that, I would say it would behoove you to look for another option with that dog. Yes.
At what age then could you reliably screen these dogs? I mean, I almost would love to be able to screen young puppies.
Yes.
But we know puppies to a certain age can have
Yes.
illicit murmurs.
Yes. So here's some news that's exciting for me. And I will say, I never thought back when I was house sitting for you, Ruth, that I would be up here talking to you like this. Ruth allowed me to escape the dormitory at Ohio State University when I was living in pure swill and stay at her lovely Golden Retriever facility where I got lots and lots of golden hugs. So what I would say is we have some exciting things on the horizon for Golden Retriever puppy screening. I just reviewed a manuscript that I think is out and released to veterinarians now that says there are some very special echo tests that you can do at a young age that predicts affected status in the future. It is not the same. It's not an aortic velocity. It's not an easy test. It's going to require a cardiologist that reads the literature, pays attention, and is willing to work with you to figure this out, okay? So it's not something you're going to do on every puppy, but it is something that you're going to do if you have a problem, I bet. If you say, I really want to breed this dog that's produced SAS before, I'm going to an outcross, and now 2 of the puppies in my litter of 6 have a heart murmur, what are you going to do about that? Well, if you could take those 2 puppies to a cardiologist and get an idea whether they were just excited puppy murmurs or whether they were really likely to develop SAS, it's going to change a lot of your plans. It's going to change where you put those puppies for homes. It's going to change the reevaluation schedule for those puppies. And this information is now out there, and it was a good paper. I read it. It looked awesome, and it predicted it well. So I think that's coming for cardiologists. Either Journal of JAVMA, JVIM, or JVC. I review all the time for those 3, and I don't remember which one it was. One of the lead authors is Cote, C-O-T-E, with a little French mark.
So what would you, at this point in time, recommend or suggest for younger dogs?
Yeah, for younger dogs, I say traditional echo if they have a really loud murmur that is present after their rabies shot.
So after 17 weeks of age or
Yeah.
6 months? I mean, I
4 months, I say.
I push it out to 6 months for a rabies, but.
Okay, I say by 4 months old, innocent puppy murmurs should be gone. Okay? Now you can still have excited, idiotic Golden Retriever puppy murmurs, just like you can have excited, idiotic adolescent Golden Retriever puppy murmurs. But if you want to know whether it's SAS or whether it was an innocent murmur in a puppy, it should be gone by the time of a traditional, vaccination protocol or 14 weeks of age. Those murmurs should be gone. And so puppies that have residual murmurs after that age, if they come in to see me, I do recommend an echo. And I think this new echo test is something I would start doing on them now. Okay? It doesn't change much. It's the same type of echo. It's just a calculation that we can make. Yes?
Will
Just timing. Has nothing to do. It's just the age. It's just a point in time that I can tell puppy owners to get worried. Yeah.
Real quick question again. A very popular sled dog du jour has now bred 3 litters with SAS.
Okay.
He has had 3 outcrosses. They're giving the breeder a really hard time. He's had 3 outcrosses now, or 2 out. I don't think there's any lineage. They're outcrosses, I'm pretty sure. What would you recommend to that breeder?
I would recommend. Okay, so let me say that I identify every golden retriever that comes in through my study as a number. So first of all, I have no earthly idea who we're talking about. But let me move on to say that I think doing outcrosses would be a reasonable attempt, and then hoping for a genetic test with every ounce of your being would be your next attempt. Unfortunately, there's not much more you can do. I would be cautious using any dog that has repeatedly produced SAS through multiple different breed lines. I think that's all I can say about that, and I'm going to remove myself from the Golden Retriever discussion pages immediately after I leave here. Yes, Leslie.
On this side, you don't roll those question marks because you have
Yep.
what happens if those are all filled in as normal too? Which can affect down that next generation?
Yeah, well, we're assuming this is autosomal dominant, which means affected dogs can show up in every generation.
Okay, so you could have everybody in the grandparents' generation as clear or normal, I'll say, but you can still make those effects sometimes. So that's the problem.
It is the problem.
Well, and you're also looking at how many siblings of those parents are any of those siblings affected. So maybe, and there's still, and you have to inject parts.
Yeah, the entire point of this diagram is to show you that there's no pattern that will help you in your breeding right now, because we believe it to be autosomal dominant.
So that's the next question. Is there a possibility of getting a DNA test?
Yes, there is. Get
I'm
there.
close already.
I'm trying hard to get there. Yeah. How long can somebody give? Yes.
My wife and I raised trained horses and all that stuff.
Yeah.
We take a lot of them in NC State, and they put them on a treadmill, and then and they work them up to it.
Yep.
Until they about keel over and stop.
Yep.
And check. Is there any kind of test of that nature that might benefit them?
We tried to do that for a long, long time. It still exists on your OFA form, the exercise test and murmur check. Unfortunately, I think in your breed, you're left with, if you do that, almost everybody has murmurs. I mean, I remember, so back when I was just getting interested in veterinary medicine, I wasn't a vet student or a college student even. I was taking dogs down to Ohio State, and they were being listened to by a cardiologist. And I remember, you guys, now I'm not going to hold it against you, but I remember hearing, oh, that one hears murmurs on everything. Now, I got news for you. We don't make that up, right? Like, that's really true. If you exercise dogs, if they're excited enough, they're going to have murmurs. And so to me, the exercise test in Goldens is just useless, unless I want to be confused, and then I do it. So that's the point. You know, I sometimes do it for students because I get bored. They're like, oh, this one sounds normal. I run them down the hall and I say, listen again. And then they're like, oh my God, it has a murmur. But I don't think there's utility in it. Yes?
To your knowledge, have any of the researchers used estimated breeding values in trying to help them determine the probability of?
Yeah. Has anyone used estimated breeding values to help determine the probability of developing SAS? So have we gotten technical on this issue and tried to figure it out? There's some information about that. I tried some of that. I calculated some heritability in SAS and golden retrievers and things. And my take on that is that it is not very good right now, but it maybe could be. If in the absence of a DNA test, if we knew all these numbers, I think maybe we could do it.
The Swedish
But my
Kennel
mom
Club.
is no.
Okay, the Swedish Kennel Club has 80% compliance.
Yeah.
And they run their estimated breeding values once a day.
Yeah.
And they have quite a bit of information on SAS. Has anybody looked at that?
No. So the question is about the Swedish Kennel Club. There are some lovely researchers in Sweden, and they do a lot of genetic research. To my knowledge, nobody has looked at that, and from my experience in the freedom of information across the pond, we haven't had such free-flowing communication. And that is nobody's fault, but the other thing I would highlight is that I'm not sure that Goldens there are Goldens here. I'm not sure that SAS there is SAS here. I'm not sure that many diseases there are the same disease here. It goes for lots of cardiomyopathies. Boxer cardiomyopathy, for example, really great genetic test here, really good information on prognosis, means not a hill of beans in Germany. No idea why. Okay? They have a different mutation that causes their disease. Their dogs develop from a different lineage. Yes?
The genesis of working with Dr. William Johnson is talking about how just each generation, the whole genetics of the same pedigree, and that common change.
Yep.
One change. That's right. One little tiny piece of DNA can make all the difference. I agree. Okay, I'm going to try to move on and get to some actual DNA stuff for you guys because there's some important information I want to get out to you before we go. And I can hang around as long as you want. This is the stuff that I like to talk about, but I don't want to keep anybody from eating. I don't want people passing out or anything like that. Okay? Okay, so here we go. No big surprise, SAS is inherited in Golden Retrievers, but we think it's autosomal dominant with incomplete penetrance. This was the kicker, meaning it can show up in every generation, and it's a devastating disease to try and eliminate from a breeding program, okay? So we feel you on that, and we're working hard. All right, so you've all maybe heard that Newfoundland dogs got luckier than you guys did. And that is that our lab has found a mutation in Newfoundland dogs that is clearly associated with subaortic stenosis. We've done lots of work in that breed, and we've found out kind of what the gene does, which is really cool. We've changed the kind of levels of this gene or inhibited its protein in fish and watched the embryos develop, and it really screws up their aortic outflow tract. So they have a really cool disease, and we know a lot about it. And there's a problem here, and that problem is that we released the genetic test. I told all the people in the Newfoundland community about it, and as it goes with any genetic test, there are some people who are interested, some people who think it's Satan's work, and then there are some people who, want to run with it and use it for everything. And so I'm a little nervous about the Newfoundland test in your breed, in as much as don't use it, okay? It is not a Golden Retriever test. I cannot patent it. The Supreme Court tells me that I cannot patent this test. I would like to patent it, not because I'm going to get rich off of it, because there just aren't that many Newfoundlands, and I work for a university. So the person that gets rich off of it, surprise, surprise, would not be me. But I'd like to patent it so that people can't use it inappropriately. Unfortunately, I'm not allowed to do that. It can be tested in just about any breed that they want to, and it has been found, the allele or the genotype has been found in other breeds. And I, because of freedom of publication and being an honest guy, I did find it in a Golden Retriever that had SAS. And so I put that in the manuscript, and people ran with it, okay? It is not associated with subaortic stenosis in the Golden Retriever routinely at all. Of those 32 dogs with SAS, none of them had that genotype. None, okay? The one dog that had that genotype was a Kennel Tech's dog. I just grabbed DNA because I needed DNA, okay? It is this really badly limping Golden Retriever that had never been assaulted or interested in breeding ever, and it came up genotype positive, and I said, that must be a mistake, and I went and I looked at the dog, and I assaulted it, and it had a loud heart murmur, and I did an echo on it, and it had SAS, and I was like, well, son of a gun, this is ruining everything. But it is there. It is present in other breeds at relatively low frequencies, and it causes something in Newfoundlands. I'm not sure it causes anything in anybody else or that we know, okay? And so if we do research in other breeds and we find that it means something, we will tell you. I can promise you guys, if a genetic test is developed for your breed, you will be the first people to know. I will not publish it. I will not give it as an abstract talk at a conference. I will call you. We will do it with you, and then we'll publish it, okay? That's what we did with the Newfoundland folks. We released it at the Newfoundland National, okay? We'll do the same thing. We'll let you guys know first. So please don't do anything with my name attached to it without me telling you that it's a good idea. I don't want anybody wasting their money, and unfortunately, I can't control the free market of the United States. And so if you get called, or if you call and ask if you can do it, the answer is yes, you can do it, okay? Don't do that. All right. It's a very cool gene. This is what Newfoundland pedigrees look like. By the way, if you guys think you have problems, this is awful. So all the black are affected dogs, all the gray are equivocal dogs. I mean, this dog is responsible for so much SAS. But I only know them by number, so nobody's getting in trouble, okay? Materials and methods. We did 93 Newfoundlands, that's all it took. I've collected way more golden retrievers than that now over time. And the problem is the breed is different. You guys have a different disease. And so we're going back to the drawing board and we're finding new ways to evaluate this disease in your breed. We're going to try this method, which we used in the Newfoundlands, just to show you how hard it is and how bad you should feel for me. I'll put this up here. So we whole genome sequenced Newfoundlands with subaortic stenosis, meaning we looked at every base pair of their DNA from start to finish across all their chromosomes and started saying how many pieces are different than the normal dog. And we found millions of changes, okay? This is what makes you, and your dog, right? Everybody's a little bit different. When we started looking at 2 affected Newfoundlands, there were 20,000 changes. That was still a lot of work. When we said in all the affected dogs and none of the control samples, there were only 2,000. When we said what ones actually change a protein, there were 20. And then when we took all those 20, went back to all of our 93 samples and said which ones follow disease versus normal, only 1 change was found. And so this is the needle in a haystack that we're going through in golden retrievers right now. We're going to get there, okay? But right now we're at this, okay? Right? No. Nope. All proteins are made up of amino acids and had nothing to do with diet. So this mutation is an insertion. These extra 3 little tiny pieces in all the billions of pieces in your DNA are what cause SAS in some Newfoundlands. I just thought that was exciting. And here's what I'm hoping we'll get to for you. In Newfoundlands, if you have this gene that's altered, you are 70 times more likely to have subaortic stenosis. Cool. That means something. Yeah. If I could tell you guys that, it would mean something, okay? It doesn't mean it all the time because it's incomplete penetrance, meaning you can have the genotype and not develop the disease. But if you knew the odds of doing something made you 70 times more likely, you would do it. We would all play the lottery if I could tell you something would make you 70 times more likely to win, okay? It's just like that. And so this is important information which we're going to hope to get you when we have something in golden retrievers, okay? And believe it or not, I love the Newfoundland people, but golden retrievers are the breed that I started doing this in because I actually like golden retrievers the best. I'm not supposed to say that at work, but I can say that in this mixed company of all golden retriever people. And so what we're going to get to, this is all boring, researchy stuff that nobody wants to hear about until later. Can we use it in other breeds? No. Okay, don't do it yet. Maybe someday, but probably not Goldens. Here we go. Let's look at some other stuff here. So we did some genotype analysis in golden retrievers, and we've gotten it whittled down to one area that we're really interested in on chromosome 21, but we still have millions of base pairs to look at on chromosome 21. This is boring stuff that nobody wants to look at. I will tell you, Rottweilers might get to go along for the ride, Rottweiler DNA with SAS looks really similar to Golden Retriever DNA with SAS. And so if I'm lucky and find something in Golden Retrievers, maybe the Rottweiler people will get it for free, and you guys can, tell them that it was all your work. Research progress in this, look, it started in 1976. We've only just got to the point where we have one mutation, but what I want to point out, okay, is that we're getting better. So look at the publications on SAS and genetics of this disease: 76, 98, 2005, 2012, 2012, 2013, okay? We're picking up momentum, and we're going to get there, okay? We've come a long way since 1976. And so I think we're going to have something interesting, and I'm hoping it's going to be on chromosome 21. And where are we now? I've now just, like moments ago, received the confirmation that all of the DNA is back from 2 completely unrelated, severely affected SAS Golden Retrievers. Okay? And so that's really helpful. Whole genome sequencing is not very common in dog research, and those 2 dogs would be the same amount of information that we use to find it in the Newfoundlands. We have oodles and oodles of Golden Retriever DNA. We can always, always, always use more, right? Because the moment we find something, we deplete all of our stores in the freezer to decide whether it's real or not, okay? But what I'd like to show you before we're done and before I open it up for more questions is how you can help. If you have a dog with SAS, please, please, please submit a blood sample, okay? If you can. Don't tell me that you submitted a blood sample for something else and can I call and get it? No, I can't. I wish that I could. I wish that it was the quality that I needed. I wish that the information was as consistent, and I wish that the extraction techniques worked across the board. They don't. I want a fresh blood sample from your dog. I know it's a lot to ask. I'm sorry. If your veterinarian tries to charge you for it, I'll happily call your veterinarian and beg them not to charge you for it. But I can't do anything other than ask for a blood sample, okay? I would love a 3-generation pedigree, okay? Your dogs are identified by numbers. I don't care who they are. I care about the Golden Retrievers, okay? They're all cute and wonderful to me, and it has nothing to do with what's going to happen when a mutation is discovered. Nothing will ever be released from my lab about dog names or pedigrees or anything, okay? If you choose to do that later with the genetic test, that is your call, and your breed club can decide what to do about genetic test results, whether they do open databases or not, okay? That is your thing, okay? All I want to do is find the mutation and let you guys do what you want with it. And I'll serve in an advisory capacity for you if you can get me on the phone, okay? I need an echocardiogram from a cardiologist. Your blood sample doesn't do me any good if it was called affected by somebody who's not a cardiologist. I'm sorry. We put too much money into these studies to take anybody else's word for it. Okay? If your dog is severely affected, this is the really hard part. I would have a really hard time doing this if I were you, but we should make a plan to help the research in the end. Okay? I'm talking about autopsies and tissue samples, and it's a horrible thing to talk about, but I am here and I will talk with you about how we do it. There are special kits that we can get your family veterinarian, and there are special pieces of that disease that I need samples from in order to give you as much information as possible about this disease when we do find a mutation. When we find a mutation, we're going to go full tilt in the lab looking for how it works, why it causes SAS, what it does, is there a drug we can use to treat it differently, all those things. But I can't do half of those without tissue from dogs that had SAS. It's the hardest thing to do. I hate that I work on the heart. It has a very deep emotional connection. It's hard to get tissue. Okay? But I'm begging you to consider it to help other dogs.
So these kits, can people, like, if they have an affected dog?
Yes. If you have an affected dog, I will give you one. Yes, I will give you the kit. If you have a severely affected dog, I will give you the kit. The kits are expensive, so I don't want to give every dog a kit. But if you have a severely affected dog, I will give you a kit, and I will make a plan on what to do in the middle of the night, and you'll have my cell phone number.
The hard thing is you're going to want the tissue quickly.
Yep.
The dog dies.
Yep. It is admittedly a commitment on your part, my part, and whoever is in the middle. Within a half a day would be okay. Within a few hours is amazing. Yes.
Would you send them to like veterinarians? I have a friend who's a vet who told her we were coming to this talk.
Yep.
She had, she knew she had cases of like.
Yep. I'm happy to give a kit to a vet. Yep. And happy to talk to them about how to take the samples and all that stuff. Yes. Yep.
So would an outfit like that be able to remove packaging?
I don't know. I think we are much smaller potatoes than that, unfortunately. I mean, we're talking, I've been really pounding the walls to get samples on dogs like this, and I've had 3, you know.
Yes, you're saying you have to get the sample within half a day, and then we still come to ship it to you.
Once it's collected, it's stable.
Okay.
I'm going to give you a special, really expensive solution that makes it all happy again. So it's just about getting your dog to the vet to take the sample. And I can give you all, you know, if anybody wants to do this or knows somebody that needs a kit like this, I will work with you. My lab manager is phenomenal. He's way better at email than I am. He's way better at answering his phone than I am. And we will get you connected with somebody who will take care of it at that moment. Okay? I promise. Yes.
When you talk about completely unrelated pedigrees, you're only going back 3 generations?
Well, completely unrelated within 3 generations. All golden retrievers are related, and many of them are very related beyond 3 generations. But in the purposes of most of our kind of big genome-wide scans, that's enough to get a statistical assessment completed. I know that there are lots of skeptics in the group, but there's one important number when you do genetics that's called lambda, which is really boring for everybody else. But as long as that lambda number approaches 1, there's no worry about the interrelatedness that I have to deal with as a geneticist. It's called population genetics, and I promise you I am well suited to do that because it haunted me for many months during my courses. And so I have one last point on here. When a DNA test is available, consider using the researcher's laboratory to get those test results. This is a plea of mine that has not a thing to do with money. I know everybody wants to think that it's about capitalism and money. It has nothing to do with money for me. But if I develop a test and I give it to the veterinary genetics lab at UC Davis, okay, that's where I go now. When I worked at North Carolina, I gave it to the North Carolina lab. So both of these labs run the Newfoundland test. When I do that and samples come in, I get access to those samples, right? So when I come back here in a year and I do a breed screening clinic and you say to me, hey, doc, are we getting anywhere with SAS? Is the prevalence of SAS going down or up? I can say, I know because I saw 3,000 tests come through and this many % are affected, right? And I can design my own form and I can ask you questions about related disease and whether your dog was treated, all that stuff. And now we have the power of information about these genetic tests. When a company takes these genetic tests and they offer them to you commercially, I get nothing from them. I get no information and we get no support from them, okay? And so if there's a large dollar disparate, difference, I understand going with a commercial company. If it's about timeline of return of samples, I would beg you to be an extra 2 days patient with the researcher's laboratory. And I would say that it's really important for us because there are 2 things about this. With this, if you use UC Davis's lab, 20% of the proceeds of that test come back to the lab for continued genetic research. They don't go to my pocket, they go to the lab, okay? They don't do anything else than that. And the test cost is not very high given what we have to do to get all that information through a university, unfortunately. And I also get all the statistics about the test. And so if you can do that and it's within your ability to do that for your genetic tests, I don't know what other genetic tests your breed is doing right now because I try to stay out of that. But if they're out there and you have an opportunity to support the researchers that develop that test, I can guarantee that they would love to have that information to help your breed. Okay? All right. That was a lot of information. I think we are done. If you have any questions, please, 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 either ask them now if you think that they're important for everybody to hear the answer to, which I have one of. Yes?
There are other breeds out there,
Yes.
Are there any that have 0 symptoms or 0 sensitivity for
Yes, almost all small breed dogs have almost no SAS.
How outrageous is dog breed try to reduce or remove from 3A, all breeds, 1 breed. The outcome is
Yeah, I think it's never. I think that's in your breed. It's never probably going to happen. That can happen sometimes with some weird defects. We like Dalmatians with urate stones. They had to go back and breed to a non-Dalmatian to get rid of it in their breed. I don't think we're there with SAS, to be honest with you, and I don't think that. I think hopefully we're genetically better than that now, and we're going to get there. Okay. All right. My contact information is on here. I do not sit in that office. Clearly, I'm here right now. I'm on clinics 50% of my time. Please don't call my office number and leave a voicemail. It is the worst idea. It really is the worst idea. It's so hard to return those voicemails, and it's so hard to remember who they are. And I can show you what happens to them. They end up on Post-it notes in my wallet, which means when I pay for something, I lose them. I'm just not equipped to deal with that. I can do a lot of things, that isn't one of them. So email, there's always a paper trail, and I can have somebody else check it if I go away. So email me. I'm way better at email, and then we can talk. I'm better at text. I would far rather you call my cell phone than my email, and I'm happy to talk to anybody about this disease, as long as you promise to not mind if I say I have to call you back. Okay? All right. Thanks, guys.